investing in technologies like robotics, and there's a lot of companies that are working on this space of robotics. You'll see some out in the forum when we leave this session this morning. One of the areas that we're looking at is we're looking at the highly repetitive, high risk, and health and safety applications to bring robotics there. You know, because this is the stuff that nobody wants to do. For example, this is the J-Bot, which you'll see outside. This is a robot for overhead drilling. You know, who wants to climb up on a ladder and drill in concrete and have that dust fall on their head the entire day for 8 hours a day? With this J-Bot robot, the tool can do about 700 holes per day. To put that in perspective, that would take a crew of 10 to 12 people to execute that same amount of work. The way this does this is it actually takes your data points from your model, and it actually, with the operator choosing which hole it wants to drill, it will actually locate and drill the hole and then mark it for you so that you can come back and do your installation after the fact. And we're working on other robotic technology, just I can't share that with you at this point in time. The second thing is smart sensors. So we're starting to put sensors in a lot of our hardware to give you real-time data on health of the application. And in this example you see here, this is a concrete sensor that you can put in before you do your pours. This actually will help you monitor temperature and actually concrete strength. And we feel that this will actually speed up your production on your projects by about 2 days. The next area is further human augmentation. This is an exoskeleton. So these overhead applications that workers have to do, you typically hear about neck injuries, shoulder injuries, and back injuries on job sites. So what we're doing with the exoskeleton is we're trying to find ways to reduce the load by about 55% for the applications that you do overhead. You can see this is an application where a drywall contractor is attaching board on a ceiling, wearing our exoskeleton. We're also investing in smart tools. So we understand that skilled tradespeople are harder and harder to find, and some of the applications that you do are life safety applications. So we're now taking our anchors, and we have this is a picture of an impact wrench with an adaptive torque control. You basically scan the box of anchors, the tool identifies the anchor, and then it sets the torque setting on the tool to ensure that the anchor bolt or the nut is actually torqued to the proper setting so it's done right the first time. And we'll continue to develop further intelligent systems that work with our tools and our anchoring systems to simplify installation. This is a picture of our newest battery technology. This battery technology actually has a unique value proposition. We basically want to take smart tools to the next level. These tools will actually tell you location, usage, and utilization for all of your tools and your projects. So basically, every time you pull the trigger on one of these tools, it writes code to the battery. When you plug the battery into the charger, it transmits the information to the cloud. And then your offices would know how many assets you have, how many assets are being used, how many are sitting idle, who might be hoarding tools on a job site that don't need them any longer, that would allow you to reposition them onto a project where they can actually make you money. But that's another technology that we have today and will continue to expand. And then finally, the other area that we're working on is we understand that cords on a job site are a hazard. They're a trip hazard, they're an OSHA fine hazard, and they're a huge drain on productivity. If you think about it, 15 minutes in the morning rolling out cords, probably 30 minutes during the course of the day moving cords, and at the end of the day, 15 minutes of wrapping up the cords, because you don't want to lose the cord and you don't want the cord to be damaged because they cost a lot of money. Now, we're not unique in this. Most companies have been trying to crack the code on how do you actually make a truly cordless job site. We spent $250 million and 8 years investment trying to solve this problem. And the problem that existed is on light-duty applications, you want a small tool with a small battery, but for big applications like cutting and breaking concrete, you need a lot of power, which means big batteries. Hilti and many of our competitors were cracking this code with different voltages. And so you can see there's 18 volt, 22 volt, 36 volt, 40 volt, 60 volt, and 72 volt batteries. But the reality is that creates an enormous amount of complexity. What we were able to do with this $250 million investment and 8 years of research was we actually are now able to run a screw into drywall and cut and break concrete. And when I say cut concrete, we can cut concrete faster than a gas saw, and we can break concrete faster than a corded tool on the exact same battery. So that's the technology that we just launched last year called Neuron. And we'll continue to expand that to actually make a completely cordless job site. As I mentioned at the outset, we spend $500 million annually on research and development. This is just idea generation. And what do we look at? As I said, you bid your work in work packages, but you execute the work through a series of applications. We say, one, can we eliminate steps from the process? And in the picture above, you see a chemical anchor. We were the first company to develop the technology that no longer required cleaning the holes for setting a chemical anchor. So we eliminated a step. Second thing is with the remaining steps, can we speed those steps up? You see a picture here of a core rig doing a wall core hole. That core rig, once it's set up, does the hole by itself, allowing the worker to go position the next place for drilling. And the core rig will start, change speed, finish the drilling, shut off the water all by itself. You simply set it up and turn it on and walk away. And then finally, we want to simplify steps. We would like you to be able to allocate your most skilled technicians to the more critical applications on your job. And so we want to always try to simplify the steps that remain. And in the picture you have there, you have our decking tool. That's a mechanical fastening. It's essentially pulling a trigger and making an attachment of metal deck to structural steel that will give you the same holding value as a 3/4 inch puddle weld. Doing a 3/4 inch puddle weld takes a skilled technician. Operating this tool can be a low-cost laborer. You just have to teach them how to squeeze the trigger. So these are the things that we're working on.